Hi everyone. I am eSIM Sarah. I will be your host for this presentation. What is eSIM? An eSIM, or embedded SIM, is basically a digital version of a regular SIM card. Instead of inserting a physical card, the eSIM is built right into the device's hardware. It connects to a carrier's network without needing a physical card and can be activated or switched remotely. eSIM are used in a wide range of devices, including smartphones, wearables, laptops, vehicles, and IoT devices. For example, iPhones from the XS model onward and Samsung Galaxy phones like the S20 through S23 all support eSIM technology. What are the differences between SIM card and eSIM? In terms of form, a SIM card is a small, removable chip that needs to be physically inserted into your phone. In contrast, an eSIM is built directly into the device and cannot be removed. To activate, a SIM card must be physically placed into the device to work, while an eSIM is done digitally, usually by scanning a QR code or through your carrier's app. When it comes to changing carriers, with a regular SIM card you have to remove and replace it with a new one. But with an eSIM, you can switch carriers or plans remotely, without touching the device. For setup effort, a SIM card often requires a store visit or waiting for a new card, whereas an eSIM can be set up instantly through software. eSIM changes connectivity from a manual, physical process to a digital, instant experience, offering greater flexibility, space savings, and eco-friendly benefits by removing plastic SIM cards and packaging into the device's hardware. Why the world is moving toward eSIM technology? eSIM technology is transforming the way we stay connected. It offers digital convenience, letting users activate or switch mobile plans instantly, no more visiting stores or handling tiny SIM cards. Growing support from manufacturers where leading brands like Apple, Samsung, and Google are already embracing eSIM, with Apple even launching eSIM-only models in the US. eSIM make global connectivity effortless. Travelers and remote workers can simply download a local or international data plan anywhere. eSIM also saves space inside devices, allowing for slimmer designs and better functionalities, making it beneficial for innovation where size counts. As environmental and operational efficiency becoming the key that empower businesses, eSIM help in reducing plastic waste and packaging. With IoT and connected devices becoming more significant, eSIM enable remote provisioning and management at scale. For consumers, eSIM give flexibility and convenience. They enable dual numbers, such as one for work and another for personal use, without requiring multiple SIM slots or devices. For travelers, eSIM deliver instant global connectivity. Instead of buying and swapping local SIM cards, users can quickly activate a regional data plan from providers like Airalo, Holafly, Ubajai, or GigSky. Beyond convenience, eSIM also free up physical space in devices, allowing for slimmer designs and enhanced performance. For businesses, eSIM technology delivers greater operational efficiency and network control. It is especially valuable in managing Internet of Things ecosystems, including connected vehicles, smart meters, and logistics trackers. With remote provisioning, organizations can activate, update, or switch network providers without physically handling thousands of SIM cards. This capability streamlines operations, reduces costs tied to SIM production and distribution, and enhances scalability across large fleets of connected devices. eSIM manufacturers have more room for innovation and space optimization. Since eSIM don't need SIM trays or slots, they save internal space inside devices. This allows for larger batteries, better cameras, or more sensors, without making products bigger. Major brands like Apple, Samsung, and Google have already adopted eSIM in their flagship devices, with Apple even releasing eSIM-only iPhones in the US. This trend shows a clear move toward fully digital and more efficient device designs. While eSIM mark a major step forward in mobile connectivity, their global rollout still faces several challenges, from limited carrier support to device compatibility and user experience issues. 1. Limited carrier and regional support. Not all carriers or regions support eSIM yet. Many developing markets still rely on physical SIM, leading to uneven coverage and inconsistent service quality. Until eSIM support becomes global, users may face connectivity gaps when traveling or switching providers. 2. Device compatibility. Only newer devices support eSIM. Older phones and tablets lack the necessary hardware, meaning users may need to upgrade to access eSIM features. Until eSIM becomes standard, this compatibility gap will limit adoption. 3. Complexity in transferring eSIM profiles. Transferring an eSIM isn't as simple as swapping a SIM card. It often requires deactivation, reactivation, or carrier assistance, which can be inconvenient, especially for users who change devices frequently. 4. Security and reliability. eSIM are more secure physically but depend on carrier cybersecurity for remote provisioning. Poor carrier protection could expose user data to unauthorized access, so strong digital safeguards are essential. 5. Dependence on carrier infrastructure. eSIM depend completely on digital carrier systems for activation and management. This creates risks such as system downtime, preventing setup or transfer. Internet dependence, no activation without a stable connection. 6. Limited user control. eSIM rely on software-based systems and carrier authorization to activate or transfer their profiles. This reduces hands-on control, making some that value maximum flexibility, independence, or privacy to be hesitant to adopt eSIM technology. 7. Adoption barriers for businesses and IoT. For enterprises, eSIMs simplify IoT deployment but bring integration challenges, including varying carrier readiness and the complexity of managing thousands of digital profiles. These hurdles still slow large-scale adoption. Today, eSIM technology is found in a wide range of connected devices. Most flagship phones now support eSIM. Apple introduced eSIM with the iPhone XS, and the latest iPhone 14 and 15 US are eSIM only. Samsung includes eSIM in its Galaxy S and Z series. Google supports eSIM starting with the Pixel 3. Wearables, smartwatches like the Apple Watch, Cellular, and Samsung Galaxy Watch LTE use eSIM to make calls, send texts, and stream data, without needing a phone nearby. Laptops and tablets. Devices such as the Microsoft Surface Pro X and Apple iPad Pro include eSIM, allowing users to stay connected anywhere without Wi-Fi. Automotive and IoT. Cars from BMW, Tesla, and Audi use eSIM for navigation, diagnostics, emergency calls, and updates. In the IoT world, eSIM powers billions of devices, from smart meters to logistics trackers, offering remote setup and flexible connectivity. In the future, eSIM technology is quickly becoming mainstream across smartphones, wearables, vehicles, and IoT devices. Growth is driven by digitalization, the expansion of IoT, and sustainability goals that reduce plastic and waste. eSIM also delivers greater convenience, allowing users to switch networks and activate plans instantly. While challenges like carrier support and device compatibility remain, they'll fade as infrastructure and adoption improve. Thank you for listening to our presentation. For inquiries, feel free to email us at info@espincorp.com or visit our website. Thank you again.